Assalamualaikum and good day to my lecturer, Dr. Januar. So for today, we would like to do a presentation for project titled Scooter for the subject of BMM3293, Finite Element Method. So this is our team members, starting with me, Muhammad Anwar bin Muhammad Sabri, Liu, Al-Zazril, and Lau. So for introduction and objective, I will be presented by Muhammad Anwar bin Muhammad Sabri. So this is a table of content. So for introduction, a scooter is a two-wheel open motor vehicle which is light-headed. This motor vehicle is used by the driver sitting or standing over an enclosed engine with their legs together and their feet resting on the floorboard. It consists of footboard mounted on two wheels and a long steering handle to hold safely while riding. The first motorized scooter for adults, known as the Autopad, was developed in 1913 and then patented in 1916 by inventor Arthur Hugo Cecil Gibson. From 1915 to 1922, the Autopad was very well designed by Arthur, as it features 10-inch tires and an air-cooled 4-stroke 155cc engine on its front wheel, which could reportedly generate speeds up to 35 mph. For easy storage, the Autopad was created in such way that the steering rod is easily collapsible. Nonetheless, weighing over 100 pounds, the scooter was hardly portable, so the Autopad became very much useful and was ridden by the delivery men, postal workers, and New York City traffic cops. As the time passed by, the existing scooters were modified and remodified till dates that now we tend to have a number of choices to choose from. As per that, there have been three main types of scooters available, known as the electric scooters, gas scooters, and the kick scooters. The most popular scooter, and which has the widest product line among the three, is the electric scooter. These scooters are easy to control as well as eco-friendly. Another available scooter in the market is the gas scooter. It is very enjoyable transportation and also quite relaxing to those looking for fast-moving transportation. As mentioned earlier, somehow there will be some disadvantages contained in the man-made product. Although the scooter are more comfortable, mileage and cheap, it could also be dangerous in situations. There are a lot of users who do not follow the rules and safety hazards of using scooter, leading directly into accidental issues caused by high speed. However, when a person is very cautious and maintains following proper rules while riding, there would be any problem. So then the next one is objective. The project objective is to educate students both fundamental and specific theories of the finite element method, utilizing software, computer-aided engineering technologies. So the objective for this following is to determine maximum von Mises stress, determine the first principal stress, third principal stress, determine the maximum displacement magnitude, and lastly, determine the safety factor in the overall model. So that's only for me, and I will let the others member to present the next slide. So thank you.
Hello, Assalamualaikum. My name is Al-Shazril Afiza Bizulkarnain. I would like to present about the methodology. Okay. Methodology is defined as a detailed procedure of technique used to determine some things, to select the process and evaluate information on the subject. Okay. In this chapter, the flow of the subject is provided to give a clear overview of this study. In this section, the improvement of the kick scooter will be evaluated. Okay, next, in the improvement of the kick scooter will be discussed together with the method. And then will be used, the part that have been listed will be drawn and evaluated with finite element and analysis software such as Autodesk. Okay. The KICS tutorial will be discussed together with the method that will be used, and the last one is the part that have been listed will be drawn and evaluated with finite element analysis software such as Autodesk, like I mentioned just now. Okay, the next step is we drawn and evaluate with finite element analysis software such as Autodesk. The first of all is the handlebar and stem will use lightweight and strong material due to the KICS scooter being foldable and making it easy to carry on. The second one is the fork on the KICS scooter will be made also from durable and lightweight material. It also has a good suspension system for the enjoyment of the user. I already explained it in the report. The head tube will be made of aluminum or carbon material. This is to ensure the head tube is lightweight and strong. The deck should be able to withstand up to 150 kg load on the deck. And the last one is the tire will be big and we will feel in the air. Okay, this is a component list and the CAD drawing will be mentioned for the next slide. Okay, the first one is a KICS scooter, the next handlebar, fork, deck, wheels and tire. This is the drawing that I drawn. Okay, the next one is this is a detailed drawing that I've drawn and make a full detail. I will explain on the report full completely. This is a drawing for handlebar for the first picture, and the second one is drawing for fork, drawing for deck, next drawing for wheel, and the last one is a drawing tire. Okay, the pre-processing setup and explanation. The pre-processing is the first step of Autodesk invented notion is material selection, constraint and load, mesh setting, run for analysis. The first one is the select material for this deck is aluminium. The second one is setting up the load, also involve a few steps will click load from the ribbon. And the next one is mesh setting. Smaller mesh element will increase mesh node. The rougher the mesh, it will be insufficient and misleading the result of the analysis. And last one is the step last, run for analysis process. After all the process is successful, solve all the parts by running the analysis to obtain the result of the design where the displacement stress and strain will be obtained. And finally, run the analysis by clicking the solve in next run and wait until it complete. Okay, the last slide is I will show the step. This is how the processing setup. This is how the step begins. Set the unit, set the constraint, and set material used for subcase, and set the load. And the last one is mesh setting and ready run for analysis. That's all. Thank you.
Alright, thank you to my friend. My name is Lao Chongxin, and my metric number is MS20006. I would like to carry on the presentation by title, result and discussion. Based on running analysis, there are two main components we obtain, which are displacement and wash mist stress. This section is also called post-processing, which is done after other process has been complete. Unlike linear static analysis, a single result item will appear in the tree. As you can see in the screen, this is the analysis of model before improvement. At the left, you can see that the maximum displacement is 3.217 E plus 0.6, and there are 3.217 multiplied 10 power of 6, and minimum displacement is 0.0. And at the right, the wall mist stress is 1464 at maximum, and minimum is 5.304 multiplied 10 power of minus 6. In next slide, you can see that this is the analysis of model after improvement. After improvement, model was deformed by a 3.167 megapascal compared with the model before improvement as displacement, and the wall mist stress after improvement was performed by 1.627 megapascal. After improvement, the maximum shear stress is around 79.09 megapascal. That's all for me. Thank you.
Good day, doctor. My name is Liu Zhihong, and my matrix number is MH20041. So for my part is conclusion part. So as a conclusion for this study, we can conclude that all the objectives of our study has been achieved. Have been achieved. The route was applied to the depth of our improved model is based on the material we use. This due to the different types of material consumed, different load of strength. However, we believe that there's still a room of improvement for our model to give the best satisfaction to our users. Since the technology of kick scooter is keep improving from time to time, and we also believe that the future studies can be done for improving the strength of the scooter with more advanced technology and material. So that's all from us. Thank you.